Rocket, a new era of astronomy, before and after Webb, Milky Way. Will the history of astronomy be divided into before Webb and after Webb? Many scientists firmly believe that we are at the dawn of a new age in cosmic exploration. Something profound is unfolding before our eyes, but we still don't know whether it's an error in our observations, a flaw in our theoretical models, or something entirely unexpected, a revelation that could transform our understanding of the universe. Could we be witnessing evidence of a new kind of dark matter, a strange form of dark energy, or an entirely undiscovered force of nature? If so, this could be one of the most significant scientific breakthroughs in history, a discovery worthy of a Nobel Prize. Telescope, unraveling the darkness of the early universe. Look at this image. At first glance, it may just appear to be another glowing celestial object. But what you're actually seeing is a cosmic structure so ancient, so distant, that it shines from the very dawn of the universe. This object is forcing scientists to rethink what they thought they knew about the earliest epochs of cosmic history. For decades, astronomers have debated a perplexing mystery: if the universe came into existence around 13.8 billion years ago, and if after the Big Bang, it entered a period of complete darkness called the cosmic Dark Ages, how is it possible that we are detecting light from that era? During the Dark Ages, the universe was filled with dense clouds of neutral hydrogen gas. Any light emitted during this time would have been completely absorbed, making this period invisible to even the most powerful telescopes. And yet, despite what physics tells us, scientists have been detecting faint light emerging from this supposedly impenetrable darkness. This has puzzled researchers for years. How is this possible? What could be illuminating the early universe before the first stars had even fully formed? Now, thanks to the James Webb Space Telescope, JWST, we may finally have an answer. Satellite, the unexpected revelation of Lyman alpha emissions. For the first time, Webb has detected that this mysterious early light is actually a rich source of Lyman alpha emissions. Lyman alpha emission is a special type of ultraviolet radiation produced when energetic young stars ionize hydrogen gas. It serves as a fingerprint for intense star formation, allowing scientists to study some of the earliest structures in the cosmos. However, this presents a major problem. If the universe was filled with thick, light-blocking hydrogen gas, how could these emissions have escaped and reached us? Scientists believed that Lyman alpha radiation should have been completely absorbed, making these emissions undetectable. But Webb's observations tell a different story. The new images reveal something astonishing: one, there were far more galactic mergers in the early universe than previously thought. These collisions triggered massive bursts of star formation, producing enormous amounts of light. 2. The newly formed stars created Lyman alpha emissions, filling space with ionizing radiation. 3. These energetic stars also carved out bubbles and tunnels of ionized gas within the dense hydrogen clouds. 4. These ionized bubbles and tunnels acted as pathways for light, allowing it to escape and reach us billions of years later. This means that the early universe wasn't as dark as we assumed. Instead, powerful, chaotic forces were already at work, reshaping the cosmos much earlier than we expected. Microscope, ancient galaxies that shouldn't exist. As if this discovery wasn't shocking enough, JWST has now observed 2 ancient galaxies that defy explanation. These galaxies are not like the ones we see today. They are highly redshifted, meaning that their light has been stretched to longer wavelengths due to the expansion of the universe. This places them so far back in time that they appear to have existed before the end of the cosmic dark ages. Police light, but here's the problem: according to the standard model of cosmology, galaxies could only begin forming after the end of the dark ages, once neutral hydrogen had been ionized enough to allow starlight to travel freely through space. Yet these galaxies already existed during that time. This is a major challenge for our understanding of how and when the first galaxies formed. If these galaxies are truly as old as they appear, then our current timeline for the early universe may be completely wrong. Chart with downwards trend, a supermassive black hole that defies logic. As if all of this wasn't already groundbreaking enough, JWST has also detected something else. At the heart of one of these ancient galaxies, GNZ11, located 13.2 billion light-years away, astronomers have found a supermassive black hole. The issue: this black hole is too massive to have formed through conventional processes. In our current understanding, supermassive black holes form from the deaths of early stars or mergers between smaller black holes. But given the time frame, neither of these processes should have been able to create a black hole this enormous, this quickly. This raises profound questions. 1. Did black holes form differently in the early universe? 2. Could there be an entirely unknown process of black hole formation? 3. Or could this be evidence that our universe is older than we thought? Milky Way, a universe before the Big Bang. This brings us to a fascinating idea, one that has gained increasing attention among physicists: conformal cyclic cosmology, CCC. This theory, proposed by Nobel laureate Dr. Roger Penrose, suggests that 1. Our universe is not the first, nor the only one to have existed. 2. Instead, the cosmos goes through endless cycles of birth and rebirth, what Penrose calls eons. 3. Each eon ends when all black holes evaporate, as predicted by Stephen Hawking. 4. The energy released in this process sparks the next Big Bang. Could these massive black holes and ancient galaxies be leftovers from a previous universe? High voltage sign, the challenge to everything we know. JWST has already shattered multiple cosmic records in just a few years. It has detected white tick mark, the most distant galaxies ever observed. White tick mark, the most distant black hole in the known universe. White tick mark, the most distant gravitational lens ever discovered. White tick mark, the earliest evidence of galactic mergers. And now, it has found objects that defy the very foundations of modern cosmology. So what does this mean? 1. Could the universe be far older than we ever imagined? 2. Could we be part of a chain of interconnected universes? 3. Or has the universe simply always existed, with no true beginning? Megaphone, what do you think? As we stand on the precipice of discovery, we are forced to reconsider everything we thought we knew. What do you think about these findings? Could we be witnessing a revolution in our understanding of the cosmos? Drop your thoughts in the comments.